Okay, so as far as simplifying goes, we got these two are our like terms. Remember the like terms, they have to have the same variables. So these all have x's, but those variables must also have the same exponents. So really I can just combine the x squared with the x squared. 5 minus 12, negative 7, x squared plus 8x. I would prefer that in descending order, so the order that it's in here, if you put 8x minus 7x squared, it probably wouldn't mark you wrong for that. The degree is going to be our highest power. So the highest power in this is 2, and it has two terms. So mono means one term, bi means 2, tri means 3. Because this has two terms, we would call this a binomial. So degree and type. Same here. Let's go ahead and say, let's start with the highest power, which is the end of the fourth. We have 1 plus 3. How about 4? End of the fourth. For the n to the third, there's only one of those, so I'm just going to bring that down. And then for the n squared, minus 1 minus 9 is minus 10. Once again, descending order by power, if you can. This would be the highest power, or the degree, is at the beginning. Has a fourth power, so this is a fourth degree function. 3 terms, so the type is called a trinomial. From the indicated operations, this time we're going to take this negative and we're going to distribute it across each term. I'm going to line up the terms as we go. So this minus t to the fourth I'll put below the other t to the fourth. The plus t to the third technically doesn't match with any of them, so I'll kind of squeeze it in the middle. And that should just be t to the third. Sorry about that. Then the minus t, 3t squared, I'll put below the other, minus 3t squared, minus 8t, and minus 3. So now that I've lined up the like terms, 5 minus 1, 4t to the fourth, negative 3 plus 1, negative 2, 7 minus, oop, did I mess up? See, I already did. Those are not like terms, are they? Bring down the plus t to the third. Now negative 3 does not make 0. Don't just cross those out. Negative 3 minus 3 is minus 6 t squared. 7 minus 8 would be negative t, and 3 minus 3, those do cancel out. So that would be our answer in descending order. This one's got a little bit more going on. We got 3 groups, but I'm going to go ahead and I'll line them up. So below the 2y squared, I'll put minus 3y squared. And then plus 2y plus 3. This didn't change signs because we had a positive there, so everything stayed the same. Now this negative distributes, which makes another minus y squared, a minus 3y, and a plus 6. 2 minus 3 minus 1 would be negative 2. 8 minus 2 minus 3 would be minus 9. And this is what, 17? This one is already lined up, I think. What does it say? Can't see the top of it. Subtract, okay? So I am guessing we're missing a thing here. It should be like minus this whole mess. So what's that going to do? 9t to the third minus 4t squared plus 2t plus 2. And that should be a little cleaner there. 9t to the third. And then I'm going to subtract, add, and add. So subtracting the group distributes everything on the bottom. These, 9 minus 9 is 0. You could write 0t to the third, but technically 0 to the third just is not necessary. 0 times anything is 0. Negative 4 minus 8, negative 12, t squared. 2 plus 3 would be 5t. 6 plus 2 would be 8. That's all I'd put. There are rules for these. I'd recommend that you have that on your note card if you're not sure. I see negative 2 to the third, negative 2 to the second. I end up with negative 2 5 times. Remember we discussed, when in doubt, write it out. So if you were not sure, then I would expect you to write negative 2 3 times negative 2 twice. Is that 6 of them, 5 of them, 9 of them? I get all of those answers. If I look at that, there are 5. 6m squared to the third. I know that this is going to become 6 to the third, m to the sixth. If you're not sure, write out 6 over m squared, and that's cubed, so it's going to occur 3 times. What do we have on the top? 6 times 6 times 6, or 6 to the third, over m squared would be m to the sixth. And once again, if you have more doubt, you could write out each m's and see that I only end up with 6 of them. Would not bother me if you made that, what is it, 6 to the third, I think it's 216. That would not bother me at this point. And on the previous one as well, it wouldn't bother me if you'd written that number out. Multiply, so we're going to take this 3x squared and distribute it. 3 times 9, how about negative 27? X to the squared, x to the third, makes x to the fifth. 3 and 6, 18, x to the fourth, minus 6, x to the third, plus 3, x squared. Be careful. I will have some times where somebody will have this. This is the most common mistake that people will do. If I had a plus sign here, we would not distribute it. We would just combine the like terms. So be careful. This one doesn't have a plus sign, which is why it distributes and multiplies. But if there were a plus sign, all we would be doing is adding the like terms. So that's the most common mistake I see people do, is that where the previous sections where I had adding, they'll just start distributing stuff. So be careful with that. Distributing here, the 2r distributes, 2l3, gives us 2r to the third, 4r squared, minus 10r. The same thing with the negative 3 now. Negative 3, r squared, minus 6r plus 15. Combining like terms, 4 minus 3 is 1, and negative 10 minus 6 is negative 16, and bring down the plus 15. Distributing this, I get t squared plus 3t minus 8t minus 24. T squared minus 5t minus 24. Same process here. 8x squared minus 4xy plus 6xy minus 3y squared. This is where I have people not sure. 4x times y, obviously minus 4xy, but 3y times 2x, 3 times 2 is 6, and I have y times x, which is the same thing as x times y. That's why we tend to put these in alphabetic order. That way I can see that these are both xy, xy, and I combine negative 4 plus 6 is 2, and bring the rest of them down. Do not make this. Do not make this. If you go straight to that, you have not been paying attention and you are trying to use magic tricks instead of actually doing stuff. How do we do this? We write it out. 25x squared, I see that, minus 10xy, minus 10xy, plus 4y squared. Now the other common mistake, this right here will be 0 credit. If you just write this down, you throw away those points. If you do this, don't cross these out, because negative 10 minus 10 is not 0. They combine to make negative. But if you write all this out and then accidentally cross those out, because you're not paying attention, you will still get most of the credit for this question. So please take the time, write it out, use your brain. It's there for a reason, right? Write these out, solve them. Let's do the same here. 10 times 10 is 100. V times V. 10 times 3. V times W. 3 times 10. V, W times V. I'm going to reorder. And 3 times 3. W times W. Now this one's interesting because these are like terms, but one is positive 30 and the other is negative 30. So they do zero out this time. And so all I'm left with is 100 V squared minus 9 W squared. This one's a little messier. X plus 1 to the third means, so what I'm going to do is I'm going to start by just distributing the first two. That gives me x squared plus x plus 1. So x squared plus 2x plus 1. But I still need to multiply that by another x plus 1. Distributes the same way. The x distributes across all three. X to the third plus 2x squared plus x. The 1 does the same thing, so that I get plus x squared plus 2x plus 1. Combining like terms, x to the third plus 3x squared plus 3x plus 1. What is the perimeter of this square? Well, the perimeter is where I take the side, 3x plus 9, and I add it 4 times. Why 4 times? Because all 4 sides, it is a square. All 4 sides are 3x plus 9. 3, 6, 9, 12x plus 36. That would be the perimeter. Adding all the sides. The area is where we multiply base times the height. The base is 3x plus 9 times the height, 3x plus 9. Distributing that, 9x squared plus 27x plus another 27x plus 81, 9x squared plus 54x plus 81. And that would be the area. Is the number positive, negative, or 0? Well, 3 to the negative 4th does not make the number negative. Remember, what that means is 1 over 3 to the 4th, 1 over 81. 1 divided by 81, that is not negative. So this is still positive. Negative 3 to the 4th, well, this negative 3 in the front is negative. But if I write that out, it means negative 3 4 times. These two multiply to make 9. These two multiply to make 9. Positive 9 times positive 9 is positive 81. 4 negatives make that result positive. On C, the difference is what's being raised to the 4th. Only the 3. This technically means negative 1 times 3 to the 4th. So literally it means negative 1 times, and then we have 3 to the 4th. So these still make 9 times 9, 81, but in the front is that negative. So this is negative. What's the difference? This one had 4 negatives, this one has 1. The negative is not being raised to the exponent in letter C. 3 to the 0. Anything to the 0 power is 1, so that is still positive. Negative 3 to the 0. Anything to the 0 power is 1. Minus 3 to the 0 becomes minus 1. See, that 3 to the 0 is not on the subtraction. It's on just 3. In the first group, the negative is in the group being raised to the 0. 1 minus 1 is 0. And last, negative 3 to the negative third would give me 1 over negative 3 to the third. Negative 3 to the third, if there are 3 negatives, is negative 27. So I have 1 over negative 27, or really, negative 1 over 27. Would be the better way of writing that. But either way, the result here is negative, because there are 3 negatives. Just keep track that a negative exponent does not make a number negative. It changes it to division. The negatives in the front tell us whether something is positive or negative. So that 5 to the negative fourth is not negative. That negative exponent means we are going to divide by 5 4 times. 5 to the fourth, 25 times 5. 125 times 5, about 1 over 625. Negative 3 to the 0. Anything to the 0 power is 1. Plus 4 to the 0 is 1. 4 to the negative 1 does not make that a negative 4. It makes it 3 to the negative 1. Does not make that negative 3. It makes it 1/3 plus 1/4. You can give them a common denominator of 12. So I would have 3/12 plus 4/12 is 7/12. If you're not as comfortable with that, get yourself a calculator. What do we have? 1/3 plus 1/4. That gives it to you as a fraction. Here we have a lot of things going on here. Before I deal with any of these 8s, I'm going to deal with the negative exponents. Those are not helpful. So this 8 on the top, because it's a negative, will move down. This 8 on the bottom will move up. So what's left on the top is 8 to the fourth, didn't move. Came up 8 to the second. On the bottom, that 8. Now to the first. This becomes 8 to the sixth over 8. One of those 8s cancels out, leaving us with 8 to the fifth. If that lost you there at the end, then you should be writing out 6 8s divided by 1 8. The answer is not 1. Only one of the 8s cancels out, leaving us with 5. Alright, this one I'm going to use more of the rules because there's just a lot going on. A power to a power, we can multiply those to make them x to the sixth. If you're not liking that, the justification would be to make that 1 over x to the positive third. Raise that to the negative 2, flips it, so that I end up with x to the third over 1 squared, which is this x to the third times x to the third, or x to the sixth. A lot of work. This one becomes to the negative 2, y to the second. The only reason I didn't move that one down is because I don't want a fraction up here at this point. I wanted to basically deal with the powers first. Well, we'll deal with that in a minute. And this becomes xy to the negative 2 squared would become x squared y to the negative 4. Now I would deal with the negative exponents, meaning move that x down, move that y up, x to the sixth. This y to the 4, or y squared stayed up there, and then this y to the fourth moved up. On the bottom, we have x squared and another x squared that moved down. So we have x to the sixth, y to the sixth, I brought those together, over x to the fourth, Last, we're going to cancel 4 of the x's with 6 on top, leaves us with x squared y to the 6th. Good. I'm just double checking my work rules. Y squared. Yep, looks good. Okay. This is something we didn't go too much into, but basically when I have this whole group being divided by 2y, I can separate this. This really means 8y to the 3rd over 2y minus 6y squared over 2y plus 4y over 2y plus 10 over 2y. So I basically can take this 2y and I can distribute the division across each of these terms. 8 divided by 2 would be 4. Cancel one of the y's, so y squared. Minus 6 divided by 2, 3. Cancel one of the y's is y. Plus 4 divided by 2 is 2. Cancel the y, so there's none left. Plus, now this is where I thought it was interesting, 10 divided by 2 is 5, but it's not 5y, because that y is stuck in the denominator. Writing each of these in scientific notation, the first rule said find a number between 0 and 9. I'm thinking 3. That's where our decimal will be. So I will put 3.44. Second half of this is going to be times 10 to some power. How many times does the decimal place need to move? 3, 6, 9, 11 times. Is this 11 positive or negative? Well, was our number really big or really small? I need this decimal to move to the right, which means this exponent must be positive. Same here now. First number between 0 and 9 would be 5, so I'll put 5.57 times 10 to the, how many times does the decimal place need to move? Looks like 6 times. But for the number to get really small, this had to have been a negative exponent. This we're going to actually write out, so it's going the other way. This says times 10 to the 7th, so 2.96 times 10 to the 7th is going to make that number bigger, 7 times. The decimal will move, 1, 2, 3, 4, 5, 6, 7. So we end up with 5 zeros. So 2, 9, 6, and 5 zeros. Same with this one. The difference here is that the exponent is negative, so this number is not getting bigger because we're not multiplying by 10. We are dividing by 10. So it gets smaller. The decimal will move to the left 7 times. 4, 5, 6, 7. So 0.6 zeros and then 607. And last but not least, satellite galaxy or Milky Way is known as the Large Magellanic Cloud is 1,000 light years across. Light years equal to 5, oh lordy, 1,000 million billion trillion, 5,890,890 billion miles. Write the two bold-faced numbers in scientific notation. Well, 1,000 is 1 times 10 to the 3rd. Decimal needs to move 1, 2, 3 times. This number is 5.89 times 10 to the 3, 6, 9. Actually, I think it's just 12 times 10 to the 12th. B says, now that you have them in scientific notation, how many miles across is the Large Magellanic Cloud? Well, that's easy. I would just take the total distance in light years and multiply it, right, by a conversion. Each light year is worth 5.89 times 10 to the 12th miles. So we literally are going to be multiplying 1 times 10 to the 3rd times 5.89 times 10 to the 12th. Why would I want to do that? Why does the scientific notation make our lives easier? Because 1 times 5.89 is just 5.89. Times 10 to the 3, 10 to the 12th makes times 10 to the 15th. And that is how many miles the Magellanic Cloud is.